All right, welcome back, everybody, to another episode of Only Med Terms in the Building.
Yep.
Here today. So we're moving on to Unit 3 today in the course, and with that comes kind of jumping to new topics, and that's going to be about molecules, cells, and tissues that we'll kind of explain out. I'm here with Jim Hutchins from the department. Jim, want to say hello?
Hi, I'm Jim Hutchins from the department.
There you go. Maddison?
Hi, I'm Maddison.
Okay, so we're here, and we're going to kind of just jump right in to the topics of the unit. So first, Jim is going to kind of explain Unit 3, why it exists, why it's kind of unique to our text and class. Yeah.
You remember in an earlier podcast, I was talking about the origins of the book, and we talked about where the book came from that goes along with this podcast, the book Medical English. And remember that we originally started with a spreadsheet, which was just a whole bunch of words. We went out as you collect butterflies and collected words from medical terminology books, from our anatomy and physiology textbook, and now we're in the process of collecting from the pathophysiology textbook. This is an ongoing process of collection. And then broke those words up. Well, along the way, I think we all teach anatomy and physiology, and as teachers we found that students were really getting hung up not on the chemistry per se, was my feeling, but on the words associated with chemistry. And so I really felt a need as a teacher to help the students understand the words weren't that hard. I have a riff that I go on, speaking of epistemology, another word, but I have a riff that I go on where I say, science in general is only understood as metaphor, and our explanations with science are only as good as the metaphors that we use. And so up until very, very recently, nobody had actually seen an atom, and yet we needed a metaphor for an atom. We needed the atom as a metaphor, as an explanation of like how the world worked. And a lot of physics and physical chemistry is about in the late 19th century, early 20th century, how they discovered that atoms weren't what they thought they were by shooting things at them and finding out that there was a lot of empty space in an atom, for example, and they had to change their metaphors along the way. And so students are getting hung up on the metaphors, and I just felt like if we had something like this, like what we're doing now, where we started to tell it as a story, that's much more natural for us as humans, is to understand for example, the Iliad and the Odyssey, the earliest stories that we talked about, are metaphors for the formation of the Greek state and democracy and why our people are better than your people. Those are all metaphors, really. They're stories that we tell ourselves, and it doesn't matter, honestly, whether they're literally true or not. What matters is how they make you feel. And so whether you can visualize things that you couldn't otherwise visualize through these metaphors. So students were getting hung up on this, and I thought, well, I don't know of any medical terminology textbooks. So I'll stand corrected if anybody has any. But I'd never seen this material in a medical terminology textbook. And yet, for example, in our program in health professions, we have medical lab sciences, where it's absolutely critical that students develop the ability to use these words that we're about to introduce you to, and to be understood, just the same as words that describe signs and symptoms, or words that describe different diseases, or surgical techniques. Medical lab sciences is part of the hospital, and they do a lot of good work and have saved a lot of lives along the way, including mine. And so let's talk about that. Let's introduce the students to that as part of a medical terminology textbook. I honestly don't know, frankly, why it was never in those books before. But people were afraid of it, I guess, or they thought it was strange, and I got a lot of pushback, as I was telling you guys offline. I got a lot of pushback on this, and I am happy sometimes. Sometimes my stubbornness has gotten me divorced, but sometimes my stubbornness has actually resulted in something good, and I'm pretty proud of my stubbornness in this respect, because I think we'll see as we do this podcast that this was a pretty cool unit. And I think it's going forward is going to do a lot of good, not just for medical terminology students working in hospital settings or clinical settings, but for our students in anatomy and physiology physiology and pathophysiology.
Yeah.
Right, and I think that's the goal, a lot of it too, like you were just mentioning, where a lot of the goal in the making of this book and this text and where the words come from is to have success in those later places. We want to introduce them now so that you can draw on that later.
Right.
Like, you didn't use words that didn't matter.
Yeah, we're trying not to just like give you busy work, right? There's a purpose to these words and you're going to most likely see them. So, yeah, trying to wrap it back around to your future careers, hopefully.
Yes, along the way. So with that, a little bit of background is always kind of helpful, especially as we go through the systems too. We'll have to give some
Context.
explanation a little bit. It's hard to learn a word when you don't, if you don't know what a kidney is, it's hard to, like, at least an idea of what it is, right?
Well, we did that in Unit
it,
1, but we'll try to loop back around and
Yes.
actually talk about kidneys in context later.
Right, as we kind of go through each system. But here, we kind of started introducing, because Jim was mentioning atoms in his other thing, and there are certain ways that we classify things in organization. So if Maddison, you want to explain the levels
so we have levels of organization, and this is going to be a common theme throughout all of our courses, starting in midterm, our anatomy and physiology courses, as well as our pathophysiology courses. And so I think all of us have experienced students saying, well, why can't we just jump straight to the lungs? Why can't we just jump straight to the heart? And that's not because we don't want to have fun talking about the heart and the lungs, but we need to start at the very foundational base level, right? You need to understand cells and tissues before you can understand how an entire organ works, how all of those organ systems work together to keep an organism alive, how we keep the human body alive. So we start off with levels of organization, and we start off with organelles. So very, very, very small parts of parts, essentially. We then move into full cells. All of those cells are going to have different functions and different properties and a different job that they're completing in the human body. And then we move into tissues. So all of these tissues collectively come together to form organs, and then these organs come together to form organ systems. So when we talk about
an organism.
Funny how that came together, right?
Yes, it's a bunch of organs that all believe the same thing, that we can actually live.
Exactly. Yes. Their goal is to keep us alive, right? And so when we talk about the respiratory system or the cardiovascular system or things like that, we're referring to structures that have the same function, the same overarching goal, which then leads us into organisms, a full human being, and that gets us into ecosystems and the biosphere and everything larger than just one individual person. But we always talk about you have to start small so that you can understand things later down the line. You're not going to understand what the lungs are doing if you don't understand what an alveolar cell, the purpose of that is, right? So you've got to start at the foundation before we can move up to the big, exciting things.
Right. Yeah, and that foundation is atoms. I look into this, right? An atom, I guess the word means invisible or unable to be cut.
Yeah, unable to be cut, which is not, and then Tomi, which we learned already is cut.
Yeah.
Right.
Not cut.
Can't cut it. You can't cut that thing.
Yeah.
Interesting word.
Yeah.
That's where it all begins. And then, like Maddison was saying, we build them up, right? You have to basically stack these things together to build bigger things. So we go from, like you were saying, cells, or before cells, we kind of hit atoms, and then we build molecules out of those, like an oxygen molecule, big molecules like proteins. And one of the ones from the unit that I wanted to kind of bring out was a protein called albumin. It's also kind of nice because most things that end in are proteins, right? We have like albumin and titin, and the other ones you can...
Actin,
myosin, hemoglobin,
myoglobin.
So you hear the in, and a lot of times that should point out that that's a protein. And we have a protein in our bodies called albumin, pretty plentiful protein, an important one that we'll learn in future classes.
They messed up the spelling, so it should end in IN, but it ends in EN.
Yes. Well, there you go. There's a piece too. But it kind of builds off what we talked about in the previous kind of recordings as well, with Maddison's examples from the previous units about like albinism and corpus, or we didn't do corpus albicans, but you
Candida
did
albicans.
Candida albicans is one you did. So in this, right, it means white, just like those did, right? The root of that comes from white, and really it meant like the white of an egg, probably cooked, to Jim's reference a lot of time, right, where it's kind of clear before. But then it turns white when we cook it, and the main protein in that egg white is albumin. And so that's kind of the origin of that name. We were chatting about this earlier too, about albumin and the root of that, like an Albus. So we're talking about Albus Dumbledore from Harry Potter, right? And that was our kind of our thing, and we're kind of going off of that, like, oh, where did they actually use the meaning of this word and naming him
Right.
in the books. So it shows here, right, that in Roman mythology, Albus, like the name of a deity, was associated with purity, innocence, and divine protection.
Yeah.
So again, kind of building off. I mean, that's probably the role they played for Harry. I've actually never read the books. Have you read the books?
No, I haven't.
No, I'm a movie watcher.
I'm going to get some major flack here, but I haven't read the books or
neither.
seen the movies.
Oh.
Yeah, now it's become like a thing, right? Like I've gone so long and I haven't seen them that now it's just like this weird fun fact that I have. I turned on one when I was younger and it had like a giant snake. I have like a thing with snakes, and so it right off, and now it's become a thing. So
And then you just learn certain things from it.
exactly.
So you can
now I
talk
just have
about
like
it.
the references. Yeah.
That's like me and the Goonies. I've never seen the Goonies.
Yeah.
Everyone's like, "You've never seen the Goonies?" And I was just like, "Hey, you
Yeah.
guys," because I don't
Yeah.
know. And then everyone leaves
Yeah.
me alone after that point.
Right.
'Cause
Yeah, I'm well aware I'm a Hufflepuff. I have no other context, but yeah.
I don't even know how you become a Hufflepuff. Anyways,
I think you're a Hufflepuff. I don't know what I am. I think the one house that always confused me, since you haven't seen it, is Ravenclaw. We don't know what Ravenclaws are. We don't know what they do. They're just
They're there.
They're just there. Okay. Hufflepuffs to some extent. I mean, we know the whole good and evil dichotomy between the Slytherins and the Gryffindors, but yeah. And as you're talking about that, I'm thinking we remind the students and anybody else who's listening that so many Latin terms have influenced our culture, and the words change our culture. For example, we didn't have this on the list to talk about, but sinister literally means left-handed, and so we see that in the abbreviations later. We're talking about OS, which is oculus sinister, which is the left eye.
Yeah.
That you'll see in a patient's chart. Well, there's nothing sinister about being left-handed, but the Romans believed that it was because you didn't fight clean, because you were supposed to show your weapon in your right hand. That was why you shake the right hand and not the left hand, is because I'm showing that I have no weapons in my hand when I shake your hand, right? And you pass on the right. You drive on the right because you're not sinister. And that keeps your weapons away from the person that you're passing.
yeah.
Right. Yeah.
And we use those ones especially in like the eyesight, special senses. I always think of oculus, like dexter and sinister, right?
Dextrose.
People know when you go to the eye doctor and you get your prescriptions, and you're going to go type them in on like your contact order online or whatever, right? And you're putting in OD and OS, and they don't know what those words mean.
Yeah.
Now watch this toss, Maddison, okay? You were going to talk about dextrose, weren't you?
Yes, I was going to talk about dextrose, which is funny because one of the words that I wanted to talk about today was glucose. And those two sound very similar. They end in OSE. So just like Justin was talking about, anything that ends in IN is a protein that we just learned.
Like me?
Yeah, exactly. Justin
just
is a
said it.
protein. Yeah,
There you go.
Justin, actin, myosin, right? But anything that ends in OSE is a sugar. And so the main one that we think about is glucose. So when we're testing a patient's blood sugar, we're testing their glucose. But we have other variations of sugar.
Are you testing L-glucose or D-glucose?
Oh,
So the D is,
D-glucose.
it's the D form, which is the naturally occurring form, right?
Oh, okay.
And so that's
what
called
you're meaning.
dextrose.
Okay,
So
yes.
dextrose and glucose are the same thing.
Gotcha, yes.
Dextrose is D-glucose.
Gotcha. I was very confused with the
I'm
L.
So
No, you're fine.
Just
So-
learning a little chemistry here with our
Exactly.
terminology.
I love it. I love it. So so glucose is our blood sugar. And so kind of the meaning of this, which I thought was really interesting, it has multiple backgrounds and a lot of French influence as well as some Greek. But the Greeks referred to it as sweet wine, or that's where it came from. And we have shortened it to sweet or sweetness. And so I think that is really interesting that it came from sweet wine, which if you have had a glass of wine inherently, it's not very sweet. It's a little bit dry. And so I find that to be kind of interesting as well. Yeah.
And later on, we'll talk about terms. We've already seen the suffixes like emia, a shortening of hemia, which means in the blood or a disease of the blood, right? And so there's glycemia, hyperglycemia. We've done the prefix hyper, which is too high a blood glucose, and hypoglycemia, which is too low a blood sugar or blood glucose.
Yep. And kind of the symptoms that those patients will manifest with, too, is important to note. So, yeah.
Yeah, so getting in those. So on our levels, we kind of mentioned the molecules. We've gone through a couple of proteins and some sugars that fall underneath those categories.
Yeah.
Let's move up into cells, and that jumps the levels. And I do like that our classes are basically organized this way.
I do
We
too.
take it here. You take anatomy and physiology. We're basically going to go up the levels
Yep.
in all of our classes we
Yeah.
go. But parts of a cell, Jim?
Parts of a cell. So we teach this in 3 units in the anatomy and physiology course. We start with membranes as a part of the cell. We go to cytoplasm and organelles that Maddison mentioned earlier that we kind of lump together. And then we've got the nucleus, which is our unit 6 in the anatomy and physiology course. And so the nucleus is the one that I wanted to kind of talk about, that the nucleus is a word that means nut, because if you think about it, the Germans that were starting to look at cells in the late 19th century, and I think Maddison's going to talk a little bit more about that, but the Germans that were looking at cells, they didn't know what the parts of the cell did. They didn't know what the chemicals were within the cells. And so just like we talked earlier about how in anatomy, when we didn't know what something did, we talked about what it looked like. That's especially in neuroanatomy, just the shapes of things,
Resembling oid, right?
Resembling oid, yeah. Thyroid, we talked about as looking like a shield, right? Because we didn't know what the thyroid gland did at that point. And so they didn't know what things did, and so they talked about what they resembled. And the nucleus of a cell resembles a nut, like a walnut, you can almost imagine, inside of a shell, which in this analogy, this metaphor that I talked about would be the cell membrane, right? That keeps the outsides out and the insides in. And so nucleus is one of those problematic words that, because it got used 3 different times by 3 different groups of people, we have to sort out in context what nucleus means. So it can be the nucleus of an atom, which is the nut of an atom, the center of an atom, which was a theoretical concept for a long time. To the nucleus of a cell, which is what we're talking about today, to something we'll talk about later on when we do study neuroanatomy, which is a nucleus in the nervous system, which is a cluster of nerve cells that are within the central nervous system. And so we use the word nucleus in those 3 different contexts, and the student has to listen carefully to know which context it is that we're talking about, because sometimes it can get a little confusing.
Right.
There you go. I was looking some things up as we kind of go too, as with interesting words, because I hadn't looked at this. But a mole, I didn't even know meant like mass or bulk.
Oh, yeah.
Because I was going to talk about diminutive terms, right? With like organelles, we've said a few times.
Yeah.
Because I think it's an important thing, right? With L being a suffix that we can discuss, and it's a diminutive term, which means to make something smaller, right? Like the thing that comes in front of it, making that thing smaller.
Right. Yeah.
So molecule is a
Small
small
mole.
mass or bulk of things.
There you go.
The mole, anyways.
Yeah, exactly.
Things I'm learning every day.
Yeah.
Because I was thinking, hey, organelle, it's the same as a
Right.
small organ,
Right.
It's these little
little
things that are like
organs.
kind of like mini organs in our cells.
But then we start to get a feeling for why there's an animal called a mole, and
Yeah.
a mole as a shortening of molecule, or as the basis for molecule.
The root, yeah.
Yeah, as a root.
Yep.
Yeah. Very interesting. Sorry, I think I derailed it a little bit.
No,
I liked it.
I don't think you did.
Okay.
Yeah. So I'm going to...
Back to the nucleus with alleles.
Yeah, we're going to talk about alleles, which, as Jim kind of mentioned, there's some German influence here. A lot, actually, especially in this unit. And when we're talking about alleles, we're talking about genetics. And kind of an interesting fact here is that allele, the word itself, is actually an abbreviation of something larger. It's an abbreviation of allelomorph or allelomorph. And so if we look at what morph means, like metamorphosis or
Mighty Morphin Power Rangers.
yes, or to just like morph into another form, it's changing forms, right? Or another form. And then allele we talk about as kind of having this broad overarching definition of a unit of inheritance. And so when we're talking about allele or allelomorph, we're talking about another form or having another form, which is really interesting, especially when you get into like sperm and egg, and we're talking about alleles from mom, alleles from dad. It's having, that morph from mom or morph from dad to create a new organism.
There you go.
Yeah.
Cool.
And I'm going to slip back down to talk about the units of inheritance and kind of riff off of what you're saying, but I'm going to go back down to the molecular level and talk about the DNA, which is found within the nucleus.
Yeah.
The DNA I like to think of as like the reference library, and you're not allowed to check books. If you're going to the Library of Congress and you can look at the original Declaration of Independence all you want, but you can't take it home and spill coffee on it. Okay, it's kind of an important concept there. Yeah, and same thing with the DNA. That unless you're a virus that gets access to the nucleus, which is a really bad thing when that happens, unless you're going down the road to cancer, in which case you're changing the DNA in those cases, and those are generally regarded to be a bad thing. That would be a capital A, capital B, capital T for those of you listening. Then we want to leave DNA alone.
Yeah.
In theory, the DNA that I was born with, that I was conceived with, even before birth, the DNA that came from the union of my father's sperm and my mother's egg, which is the creepiest thing ever, okay? I'm sorry, but, oh, man, okay. And this is what's tough about being a scientist and having to teach, is that, in order not to trigger people, I have to talk about myself, and like, I don't want to even think about this. But there was at least 3 occasions that I know of where my father's sperm met my mother's egg, and that are documented. Yeah, that I have evidence for. Anyway, at conception, we created a brand new set of DNA molecules, and the Germans, who were the preeminent scientists of the late 19th century, were the first to really recognize this. But they had a really incomplete understanding of how the mechanisms of genetics work. They set us up in terms of biochemistry, and we knew that the nucleus was somehow important, and we knew that DNA and RNA, that's in the name, deoxyribonucleic acid and ribonucleic acid, were found within the nucleus, right? They're nucleic acids. It's the NA part of the abbreviation, which is in this section too.
They just heard some sugars in there too.
Some
glucose and dextrose.
And deoxyribose and ribose. Yeah.
Hey, what's the difference between those?
Ribose, I just found out, comes from the term gum arabic. Okay, so it was isolated from gum arabic originally, and so the Arabic, ribo is where those letters come from, and then deoxyribo differs by 1 oxygen atom. Yeah. So it just has lost an oxygen atom, which you can do with medical terminology, right? It's right there in the name, so no reason to get all hung up about it, right? Because remember, they didn't know what these things did; they just were characterizing them chemically, and so it's based on a chemical characterization. Well, later on, Watson and Crick stole Rosalind Franklin's data and proved that DNA was the unit of inheritance. And
shout out Rosalind Franklin.
Rosalind Franklin for the win. Okay, it's maybe borderline creepy, maybe it's over the borderline creepy, but I have always had a crush on Rosalind Franklin. She died the year I was born, so that part's a little bit creepy, but just her mind and her ambition and her drive, one of being the few people on the planet who actually understood the science. And like Marie Curie, she died for her science. Okay, I'm convinced that she was an X-ray crystallographer. She used X-rays. Shielding was almost non-existent at the time, and she died of ovarian cancer, I believe in her late 30s, early 40s, so at a relatively young age. And so I believe that she died for her science. I believe that she was so dedicated to her science that she died for that and never got to see the fruition of her.
Yeah, age 37.
Age 37,
Very young.
Very young, and ovarian cancer, we'll talk about cancers perhaps later on, but ovarian cancer took a lot of good people before we're starting to understand it at a level where we're getting saves, as you know, from the clinic that you worked in. But that's only in the last 5 or 10 years that ovarian cancer has not been a death sentence. Up until then, it was.
Yeah, and it's very, very, this is a tangent, but it's very a lot of women do not get diagnosed quick enough because a lot of their complaints are swept under the rug by modern medicine. And they're told that they're bloated, they're told they're constipated, they're told that that's just part of your menstrual cycle, right? When in fact they have ovarian cancer.
I'll go even further, and then I'm going to snap it back. I mean, ovarian cysts, for example, which are an absolutely common symptom of menopause or a sign, I guess we would say, of menopause, and something that's really common to have during menopause.
And even before, too.
In my personal experience, not with my ovaries, because I don't have any, but with my partner's ovaries, I've seen a minimization of just how painful. You know, if it were a cyst on the testicle, you would get male doctors to sit up and take notice.
Would be stopped, right? But yeah.
And these are the same organ. They just happen to be in different locations, but it's the same thing. They come from the same primordium. They come from the same place. And so, but she was irradiating her ovaries with DNA, which was damaging the DNA. Remember how I said it's the reference library, and it should not be damaged. And so when you use X-rays, when you use penetrating radiation, it does damage the library. It does spill coffee on the original of the Declaration of Independence, and then you're in trouble. And so we just realized that with the invention of X-rays for those rad tech students. Marie Curie, I mentioned, who used radioactivity and discovered so much about radioactivity and died as a result of that radioactivity, because that was how we got that understanding was by killing scientists, right? And so the bases of DNA were chemically characterized, and they were named where they came from, the organs or the substances that they came from, rather than because we knew what they were. And so we may know the mnemonic apple trees and chewing gum, and this was something that Watson and Crick discovered in their model building, and that was validated by Franklin's data. So this was their work, not hers. But they discovered the base pairing properties that adenine and thymine bound to each other because of something we can talk about later, which is hydrogen bonding, the idea that hydrogens are kind of shared between different molecules or between different atoms, like oxygen and nitrogen and sulfur tend to share hydrogen atoms and form hydrogen bonds. So that hydrogen bonding that's holding the DNA together is A and T, adenine and thymine. And then chewing gum is the other half of that mnemonic, apple trees and chewing gum. So chewing gum is cytosine and guanine. And I'll do them in that order because it's I'm building a story and it's more interesting that way. So adenine is what we came across already. Ene is a chemical name ending. And so all these end in ene. Adenine is from glands. So we learned in Unit 1, because it's one of the 25 most common roots, that adeno, add in, and sometimes we add an O to make it sound better, is a gland, okay? We see this as adenoids in the throat, okay, which we used the suffix oid before. So resembling a gland. They don't only resemble a gland, they are a gland, but we still are stuck with that name.
Oid, yes.
Yeah. Okay, or adenocarcinoma, which is, I believe, and we can look this up, but I believe that ovarian cancer is an adenocarcinoma, right? A cancer we talked about before, the crab. Oma is tumor, and adeno means glandular tumor. So it's a tumor, a malignant tumor of the glands.
Right.
Is an adenocarcinoma, and that's why I'm picking on ovaries, because
we
they're
just talked about
gland.
it. Yes.
That's adenine. It was originally isolated from glands, and so it was called adenine because this is the ene, the chemical substance, which I'm getting out of a gland. Thymine is from the thymus gland, which is we haven't talked about before, but the thymus is often confused with the thyroid because they have really similar names. But the thymus is where we isolated thymine from. And so the thymine comes from a gland called the thymus, which is in the vicinity of the heart. It's in a part of the body called the mediastinum, the middle place And so the middle place is in the chest. I like to tell students in anatomy that the mediastinum is everything in the thoracic cavity, everything in the chest, except the lungs.
Yep.
So you go, reference to Werewolves of London by Warren Zevon. So you go rip the lungs out, Jim, because my name is in it. Then you rip the lungs out, Jim, and you end up with the mediastinum is what's left behind. Do you remember, Justin, what the origin of thymus is? Because I'm blocking on that right now.
Yeah, thymus is Latin from Greek. I always love those two. It's like it's from the Latin, from the Greek. And here it says that thymos, right, means like a warty you can't say the word. You say it for me.
Excrescence?
Yes.
Yes.
I was a speech therapist.
I'm execrable, so
some
so
words
I can do
don't,
excrescence, yeah.
They just
don't work for me.
Yeah.
But there's some other things in the thing. It could have multiple meanings. It can mean like anger or heart and soul. So I don't know if it's kind of in the heart area, right? Like maybe that's where it came from. There's things that it could be from, like thyme, the herb.
Yeah.
You say thyme? Is that how you say it? Yeah.
We got time.
Because all the
Keep
Greek
going.
words and those things are all kind of from that.
Yeah.
Okay.
But the warty, you say the word.
Excrescence.
Excrescence.
So a warty-looking
thing.
gland. Yeah. So what it looked like. We're back to naming things after what they look like.
Yeah.
Then we have chewing gum, part of the mnemonic. So cytosine, that's an easy one because it's got a little bit of sugar thrown in there, okay? But it's cytose. So cyto, we learned in Unit 1, is cells.
Yeah.
And that one appears all over the place.
Yeah, everywhere.
Okay? Cytoplasm is
Cytosol.
the cytosol, okay, cytosis, which we're going to get to when we talk about the blood. There's a lot of cytoses in the blood. Notice how I slipped in the plural as well. Okay,
Very good work.
there you go. Because it ends in is, and so when we have the plural, because it comes from Latin, we do cytoses.
Yep.
Okay. And then finally, my personal favorite, and again, I want to talk about the creation of the book because this was, to get an insight into my weird personality, this was a huge struggle that I had with myself. I spent literally hours thinking about this because I wondered if I could get away with the S word when I was talking about guanine because it comes from bat poop. I believe was what I finally decided on.
Yeah.
I thought about bat crap, which I think I can say. I think that's one of the approved words because I have lots of friends who use that word openly, okay? Not the S word so much, but the C word, okay? Bat dung, okay, I thought about, okay? But it comes from bat guano,
Yeah.
okay? And so guano is, of course, bat poop, which
Go with
was
feces.
Yeah, and that's a whole historical thing about how many lives were lost in the 19th century fighting over bat poop.
Yeah.
True story. You can look it up.
Yes.
Okay.
That's your homework.
I would say millions of people have been killed over bat poop. In the 18th and 19th century. That was what a lot of the explorations and the colonization of the Pacific Islands was about, bat poop.
Yeah.
Okay, strangely.
Yes.
Yeah. The HMS Bounty, I believe, was, among other things, there to collect bat poop.
Okay.
Okay. And so we can get into that when we do the agriculture podcast later on, okay, and history of agriculture. Because it was needed for fertilizer is the short version of the story. And it increased the productivity of crops so much that it was of economic value in the same way that you'd say in the 20th century that oil was of economic value,
Right.
same ideas that people fight over things that have economic value. And so that's my favorite is guanine, okay, of those four, because it's named after bat poop, and that's where it was originally isolated from. So if you have any suggestions for me, we can always modify the book. That's the beauty of it, okay?
That's true.
But
Live in class.
Yes.
Yeah.
Pull it up right now.
Yep.
Okay, we can pull it up on the screen and
Edit it.
if you have a better word than poop, but I think that hits the right combination, and you can see I spent time thinking about this. The right combination of levity, and being leviosom. Speaking of Harry Potter, okay,
Harry Potter Day.
lifting something up or lightening things a little bit. Same combination of levity and seriousness.
Yeah.
Poop just kind of hit that sweet
Yep.
spot for me.
All encompassing.
Yes.
kind of riffing off of that, Jim, because we've mentioned the nucleus and the organelles, and you've mentioned the plasma membrane, and on there we have receptors. And I was thinking off of, because you did adenine, right, this chemical name from a gland, right? We have adrenaline also, which is a chemical name from the thing they got from the adrenal gland. So rather than just a gland in general, right, they choose adrenaline, adrenal in.
Yep. What does adrenal mean?
Yeah, that's what we're getting at, right?
Yeah.
So,
that's what I was wondering.
It's got a prefix, ad,
Yep.
right, which means like near, toward.
Yep.
Some people might say upon,
Yep.
those type of things. And then renal for
Yeah.
kidney.
Yep.
I was thinking Maddison would say it for me.
Oh, kidney, for the kidney.
There we go.
That was your
kidney.
cue.
Right?
Yeah.
So it's, near, upon,
Yep.
adjacent to the kidney.
Yep.
The adrenal gland is where that kind of came from. And on our plasma membranes, we'll have receptors, which are these molecules. Yes. Sorry, I had to check on my mind if I'm using the right terms. That certain hormones or things like adrenaline, right, this chemical from the adrenal glands can bind to.
Yep.
Adrenaline receptors.
Yes.
Yeah.
And Jim's going to love those when you get into neuro one day.
Well, ergic is a suffix that you'll hear that means acting on or moving. It comes from ergon, energy, or ergonomic chair. Okay, it means doing work of some sort. And so the molecule is doing the work of activating this pathway inside of cells through the adrenergic receptor.
Yeah.
Which
is the same receptor for an epinephrine.
I'm angry about this.
Yes. Well,
something
Jim, why did you
do
it? You shouldn't have done it, Jim.
I should not have, and I did not. I don't think I've told you guys even offline this story before, but I remember when I was in 4th or 5th grade, somewhere along there, I learned that in 7 billion years that the sun is going to go supernova, or it's going to go red giant, right, and swallow the Earth.
Right.
Yeah.
It's going to be as big as Jupiter, the orbit of Jupiter, and so the Earth is going to get swallowed. And not having any conception of large numbers at that age, I remember thinking, well, we need to do something about that.
This is a real problem.
Congress should convene, and come up with a plan. What are we going to do about that?
Right.
Not understanding billions.
Nothing.
Yeah.
That's what we're going to do about it.
That's what. Yes. Well, even more so now. But
right.
Yeah. So we should do something about this adrenaline epinephrine problem.
We.
Yes. They. Okay.
They.
I'm sorry.
I like they better.
They need to do something about it. They need to do it. I don't need to be involved at all.
Anonymous they.
They need to fix it.
Byproduct of the finished solution.
But yeah, so it's really the same thing, right? Adrenaline, which is really like a trademarked British loss. I think that's the kind of the history. Epinephrine's more what we use here, but it's really the same thing, right? And all coming from the adrenal gland. But epi being upon, nephrin, right, for the kidney, and then we got in again, right? Epinephrine, adrenaline. They're just really descriptions of the adrenal gland and where it's located, and where the thing is coming from.
So, my favorite example is always, what if a tiger came into the studio here and started chasing us around? Well, we get a big shot of adrenaline, right? It would come from our adrenal gland. But you can get the same effect when in the clinic a patient is going through anaphylaxis. Phylax is a word that means protection. Anna's backwards.
Right,
so this is a backwards protection. It's a protective mechanism which is operating in reverse to cause you harm. And so when a patient goes into anaphylaxis, the very first thing, and sometimes the only thing you need to do, is to give them a shot of epinephrine from an EpiPen. Okay. And I'll tell the story later about why EpiPens cost $800 a pair in the U.S. and only $80 in France, but another story for another day.
Well, did they have adrenaline in them?
They had adrenaline in them, yes. Maybe that's why. One of the pens is adrenaline and the other one is epinephrine. That's what it is.
The same but different. Different, yet the same. Well, good. I mean, that wraps up the ones that I had. Maddison, any other ones on that?
No, I think mine are about the same too.
Okay, Jim? Any last thoughts?
Those are the only med terms in the building for this podcast.
For this unit.
See, that was like a rap. See
it
how
was.
Not that kind of rap, not with an R.
That
but,
should have been the end, is what you're saying.
You could do a rap with an R to end it if you really wanted to.
I could not unless you give me a beat, and then I can get some flow going. But I can do karaoke, as I demonstrated last episode, but I'm not so sure about rapping.
We'll work on it. That will be a project.
We'll put a rap on Unit 3.
Yep.
And we'll uncover some more terms in our next one.
Yep.